Good morning, good afternoon, good evening, everyone. This is another weather forecast discussion for January 19th, 2022. Of course, my name is Nate. I also go by Hockey Boy and Nate. Still watching our storms very carefully as things start to become a lot more clear than they were when we made our last video. And we can see both our developing low pressure systems start to come into view here with the water vapor satellite imagery. One being up here at the lagging end of that boundary that we were talking about with the Alberta Clipper moving on into portions of Quebec, and then our other developing low pressure system, which is still lingering over into portions of the southwestern United States. Eventually, these low pressure systems are going to really fall into line, but the big thing here is that from this leftover low pressure system that's up here in the portions of Ontario and Quebec, this is really starting to create a lot of significant wind shear that is starting to pummel areas here of the Ohio River Valley heading off in towards the eastern portions of the United States. And we actually have a severe weather event because of this into portions of eastern Texas, into Louisiana, Arkansas, as well as into Mississippi. So areas over here need to really watch out, as you do have a severe thunderstorm watch, which is in effect until 7 p.m. Central Standard Time. And I would highly recommend that if you are under any sort of warning, you get into a sturdy structure so that you may be safe from any of these storms. Now, sooner rather than later, these developing low pressure systems that I was talking about are going to start to fall into line and create some wintry precipitation towards wherever they go. The low pressure system in the southwestern portions of the United States is going to start to turn a little bit more easterly and is going to start to create wintry precipitation for portions of southern Texas. And then this other low pressure system, this upper level low, is going to pair with this developing low pressure system that will develop within the next few days and create some wintry precipitation across portions of the coastal Carolinas. But in the meantime, we have this stationary boundary that's set up in place connecting from the low pressure system in Canada all the way down towards portions of Mexico. And there's going to be some consistent precipitation across much of these areas here of the southeastern United States. Just to zoom in here for the people impacted by the 2 out of 5 on the severe weather scale, you can clearly see the areas in dark green outlined as the 1 out of 5, and then the areas in between, kind of like a egg yolk in the middle of some sort of avocado. You can see how we have the 2 out of 5 on the severe weather scale right over here towards portions of Shreveport, Houston, Monroe, as well as almost all the way towards Jackson, Mississippi. So watch out for there. There is a 5% chance for tornadoes, but it is more located along the border of Louisiana and Texas. So if you guys live along those areas, I highly recommend watching out, specifically from Beaumont and further north towards areas near Alexandria. And we're going to go ahead and shift over towards the weather models, but before we do that, please be sure to subscribe if you are enjoying the type of content that I do provide here, because I only provide content whenever weather seems to be life-threatening, so that way you guys know when impactful weather could be coming on through, whether it's hurricanes, tornadoes, winter weather, ice storms. I cover it all on here, so please be sure to subscribe and hit that bell button to stay up to date with all the latest information with that, as well as hit that like button down below so that we can spread this with as many people as possible on YouTube, because that is how YouTube works. If you hit the like button, my video gets shared with more and more people, and you're essentially helping me spread the information with as many people as possible. So first things first, we're going to take a look at the severe weather output from this, and we're going to be taking a look at the 500 millibar wind shear just to try and get an idea as to what exactly is happening in the atmosphere. And we're looking up about 6 kilometers above ground level. So this is the upper level winds in the atmosphere that is basically flowing our jet stream. Of course, the time is above me in Eastern Standard Time, so if you want to convert to your time zone, you can, but for people who are in Eastern, you guys have the luxury of having that. We're going to be taking a look at the North American model, or at least the 3-kilometer version, which is a lot higher resolution. So you can see our developing low pressure system over here, our other developing low pressure system over here, some very significant wind shear that is across portions of the United States, kind of combining over towards the northeastern portions of the United States. So this map so far is relatively accurate based off of what's happening right now. Now, as we play this on through, you can kind of see how we have some pretty significant wind shear that starts to pop around between now and the overnight hours here for Wednesday for the severe weather event. So we have some enhanced level of wind shear here within this general vicinity, and this will continue to be the case as this pushes on through into Thursday, to the point where both of these jet streams, the one that's coming from the southern portion of the United States and then the other one from the developing low pressure system, is going to start to merge and form this giant stationary boundary to where all the precipitation is going to start to congeal. On the other hand, there is the other developing low pressure system that's bringing a lot of cold air behind this, and that's going to create your wintry precipitation for the southern portions of Texas as this moves about. And as we continue to play this out, you can actually see that both jet streams continue to merge into one, and the other developing low pressure system kind of becomes a little bit elongated. It's still there, it still has a bit of a low pressure system with that, as well as the one down towards Texas, but it is a very elongated low pressure system as it moves about, and it ends up just creating this very strong shear that just pushes on through the United States. So that is the reason why we have a bit of activity that is possible across portions of the Carolinas. One, because you have a lot of moisture that's near the Atlantic Ocean, and two, because you have the wind shear that's basically pushing all things together. Now, if we backtrack a little bit to the severe weather aspect, you can see that we're taking a look at the 850 millibar wind shear, which is about 1 kilometer above ground level, and we have some steady shear coming from the south, more of a southwesterly shear actually, to where this is actually bringing in moisture from the Gulf of Mexico into the area to watch. So we're definitely going to have to watch out for how this continues to move on through, and you can actually see how this works here with the current dew points of the NAM 3 kilometer. You can actually see the dew points in the 60s to almost upper 50s in some spots, a little bit further north of the major warm pool. And as this moves on through, you can see how that big cold front is expected to push on through and absorb most of those dew points, creating your showers and thunderstorms. And that's the big thing to be wary of because of that 2 out of 5 on the severe weather scale. This is the reason why we have that. Now, for those who want to get a little bit more technical, we're going to take a look at the convective available potential energy, or CAPE for short, which is basically the energy levels of the atmosphere to which can actually form severe weather. Now, you want about 1,500 joules per kilogram and above in order for you to get this severe weather. So you're going to have to take a look for some of these green yellowish areas, and we do actually have that here. Now, for people who are curious as to how CAPE actually works as we continue to move on through this loop, CAPE basically is the measurement between warm air rising and cold air sinking. So the displacement between the two is how much energy there is. The more displacement, the more CAPE, the higher likelihood for thunderstorms to either form or sustain. And so because we have enough energy for this and we have enough wind shear, that is the reason why the Storm Prediction Center has issued a 2 out of 5 in the severe weather scale for some of these areas. So if we take a look at the timings of this event, you can see how thunderstorms begin to kind of pop off across the board right around the time in which this video gets released, and you can see the massive elongation of this line from Tennessee all the way into northern Mississippi, Arkansas, and then down towards the watch area from Louisiana down into Texas. And this is expected to move on through the Houston area by around 4 to 5 p.m. So as I said, about the time in which this video gets actually released, and this will continue to push on through into portions of Louisiana and further on through into Mississippi as this moves along. And you'll actually see how this forms into a giant line that'll just push on through much of the state, and that'll start to weaken more and more, especially as you go further and further into the overnight hours and into the early morning hours of Thursday. But then watch this as this continues to move on through. You can see on Thursday, specifically around midday Thursday into the late evening hours of Thursday, you can see how you're starting to get a lot of freezing rain and sleet that is starting to appear across portions of southern Texas. And this is the one portion of the wintry precipitation that I was talking about with that developing low pressure system. Of course, moisture will not be a limiting factor in this environment as we take a look at the 850 millibar relative humidity. Of course, areas in the greens and almost the kind of purples is high humidity, and then the areas in brown is low humidity. And in the area that we were seeing a lot of that precipitation, you can see humidity values in almost up to 100%. So that is not a limiting factor here within this environment. So with that being said, let's get a little bit more technical now. Let's take a look at the 700 millibar temperature, which is in Celsius. Now, the big thing here you need to remember here is that 700 millibars is about 3 kilometers above ground level. So you have your snow that starts to form relatively high up in the sky. You can see how it's a lot of freezing temperatures here within a lot of these whites. You're going to want to pay attention to these whites here because this is freezing level and below. So basically everywhere else that's north of this, this is freezing level. So let me outline this once again. And as we change from this over to the 850 millibar temperature, which as I said is about 1 kilometer above ground level. So as we change from the 700 millibar temperature to the 850 millibar temperature, you can see how the freezing line starts to recede a bit further towards the north and west, and we actually are going to want to change this color here so that you guys can have a general idea as to what's happening here. So remember, everywhere above the black line is where snow is starting to form and it's falling down, but then as it gets towards the 850 millibar temperature level, which is 1 kilometer above ground level, areas in between the yellow and the black is melting into rain. So remember that as that moves on through. And then as we show you the surface temperature here, you can clearly see how there's some areas that are in the bright purples and even into the whites in some spots. And this is the reason why there could be some freezing rain within some of this general area. Right within here is where I would watch out for some freezing rain the most, especially if you have some of these whites. You're definitely going to get some freezing rain within that general vicinity. So flash freezing is definitely possible within this general area, but I do not think that snow will be very likely due to the fact that there is not enough widespread whites for there to be consistency. So definitely something to note with this storm here in southern Texas. So looking at around that same time, you can see the total amounts of freezing rain anticipated within this area, only in upwards of a ½ inch of freezing rain, so definitely something to where people should monitor this, especially if you are traveling. There could definitely be some very hazardous icy roads out there, and potentially even some power outages is possible, but it's not as significant as some of the areas a bit further towards the north and east is actually going to get, but still pretty cautious that you should probably be within this environment. Now, as we shift our attention here from the southern Texas all the way through until just practically the entire eastern portion of the United States and southern portion of Canada, you can see how this massive boundary is starting to push on through, and that'll continue to surge on through from Wednesday night into Thursday, with how on the back edge of this line you can see snow start to form, and in the front edge of this line you can see a lot of rain that's starting to form. And what's happening here is you have a lot of the warm air on the southern end and a lot of the cold air on the northern end that is kind of pushing up against each other, and eventually what's going to happen is this line is going to continue to creep slower and slower towards the coastline, and it's basically going to sit there. That's basically what we like to call a stationary boundary, because you don't have enough cold air or warm air to basically push it in one general direction. And it seems how you have wind shear that is just basically surging up along the entire boundary here. It's not really going to move a whole lot, so you're going to get a lot of precipitation within this general area. So watch as this moves on through. You can see a lot of wintry precipitation that start to form along portions of the northern end of that line, but then this line kind of just stalls along the coastline, and this continues to be the case all the way through until the next upper level low pressure system comes in behind this and starts to force this out, as well as a new low pressure system that forms off the coast and begins to push off towards the north and east. But otherwise, you can see the consistency here of the amounts of freezing rain, sleet, and snow that occurs just to the north of this boundary, practically from the coastal Carolinas and Georgia all the way further towards upstate North Carolina, even into portions of upstate South Carolina and portions of Virginia Beach, Norfolk, and even areas along Ocean City and Salisbury, as well as Chesapeake. So you guys need to watch out for that. If this continues to be the case, you guys could see some abnormal amounts of wintry precipitation. Now, with that original blast from the line that moves on through, this is the preliminary snow totals from that, and you can see how some areas don't even get a whole lot. At maximum, 2 to 3 inches, maybe even up to 5 inches is possible across portions near DC and Waldorf, Maryland. So it's just going to have to watch out for how this moves on through, but this level is not as significant as some of the areas in the past. So watch out for the snow. Could be slippery, but it's not major. Now we're going to do the same thing that we did with southern Texas over here towards areas of the Carolinas. You can see how there is a lot of moisture here with the relative humidity at the 850 millibar level. So the moisture is not the limiting factor here within this environment either. So you know the drill. 700 millibar temperature, outline how everywhere north of this black line is going to be freezing at 3 kilometers above ground level. If we switch this over to the 850 millibar level, which is about 1 kilometer above ground level, you can see how the freezing level recedes a little bit further north, and so areas in between the black and the yellow line goes from snow to rain, and then as this switches over towards the surface, a little bit different color temperatures here, but it doesn't really matter all too much because this is in Fahrenheit, and you can see practically the areas here of the light blue and further north of that towards kind of the reddish areas. this is where it's back towards freezing. And this is the concern here for much of these areas, is that the areas in between the yellow and the blue line is where you can anticipate a lot of freezing rain or frozen precipitation possible. Now, anywhere north of the yellow line can anticipate some snow. That's more than likely what you're going to get, but snow is definitely a likelihood within some of these areas, so watch out for that. And then areas south of the blue line, that is where you guys are more than likely going to get rain, so just something to consider as this moves on through. So some of the totals here from the NAM 3 kilometer, of course this could be a little bit overdone, but at the same time we're going to want to take a look at all different scenarios here to try and get you guys a general idea as to what the worst could potentially be. And taking a look at the freezing rain, you guys could potentially get an upwards of 1.25 inches of freezing rain, especially from areas here along the Outer Banks all the way down to Wilmington towards Myrtle Beach and a bit further down towards Charleston. So really something that we're going to have to watch out for how this plays out. And just to get some reference with some of these other models here, you can see the Euro model also has that solution, except it's a bit further towards the north and east, specifically north of Wilmington. So really something that we're going to have to monitor as to where exactly these low pressure systems move on through, as well as how far that warm moisture actually seeps in towards the coastline to determine as to what type of precipitation these areas could get. And of course, after all it is said and done, you can take a look at the total precipitation amounts anticipated here with the NAM model, and you can see how there is anticipated to be an upwards of at least 5 inches over here north and west of Norfolk. So definitely something to monitor as this moves on through, and you could actually see heavier amounts of snow depending upon how much moisture actually seeps inland. So definitely something to watch out for. Now, there are still some questions here within this event. The big thing here is, as I said, how much warm moisture is actually going to seep inland, and will the freezing rain and snow actually be pushed a little bit further towards the north and west? Of course, on the other hand, how much cold air is going to be seeping in behind this, and where is the stationary going to exactly set up? Depending upon where the stationary boundary actually sets up can determine as to which areas could precisely get snow, freezing rain, and even rain. So that's going to be it for me, guys. Thank you guys so much for watching. If you did enjoy the video, please be sure to leave a like, subscribe if you're new, turn on notifications, share this with friends and family and on social media. Also follow me on social media. Link will be in the description down below. Our Give It To Me Straight question of the day will be, at some point in your life, what was the maximum amount of snowfall that you actually have seen? Whether it was from a blizzard or from a winter storm or whatever, let me know in the comments down below. I'll pin the person who is the most interesting. And of course, I will see you guys next time. So peace out, everyone, and turn on notifications to stay up to date.